here we go. So here's question number 2. This is the quiz. So this is the Chapter 3 quiz, which is due next time. Okay, so here we go. So special deck of cards has 20 cards. 9 are green, 7 are blue, 4 are red. When a card is picked, the color of it is recorded. An experiment consists of first picking a card and then tossing a coin. Oh, 20 cards, and we're going to do what? We're going to pick a card and toss a coin. How many different things can happen? 20 cards, and then flip a coin, which can go 2 ways, heads or tails, right? So let me help you with that. So here's question number 2. You're going to pick a card. There's 20 cards. And then you're going to flip a coin. And when you flip the coin, 2 things can happen. So how many total different things can happen? 40. You multiply those numbers. Do you realize that? Let me show you with a tree. Right? When you pick your first card, you can pick the first card, second card, third card, fourth card, all the way down to the 20th card. Right? 20 different things can happen when you first pick the card. You with me? And then after you pick the card, you flip the coin. So after getting the 1, you could get heads or tails. After picking card number 2, you could get heads or tails on the coin. After getting card number 3, you could get heads or tails on the coin, etc., all the way down to getting card 20, heads or tails. You see how it's going to double the number of total things that can happen? You can get card 1 and a head, or card 1 and a tail, or card 2 and a head, or card 2 and a tail, or card 3 and a head, or card 3 and a tail, etc., all the way down to card 20 and a head, card 20 and a tail. So how many different possible, this right here is the sample space. How many things in that sample space? 40 possible. Does that make sense? 20 different cards, each going with a head or a tail. 20 cards, each going with a head or a tail. 40 different things are possible. So that's what they want. How many elements in the sample space? 40. Now let A be the event that a red card is picked first, followed by landing a tail. So they're saying, what's the probability of getting a red and then a tail? Well, remember, probability is always going to be something out of 40, isn't it? 40 different things can happen. Out of the 40 different things that can happen, how many are a red card and a tail? How are we doing? Am I making any sense here? So how many red cards were there? 4 red cards. And for each of those cards, you could have with it a head or a tail. But they only want me to count the ones with tails. So there's going to be 4. Right? That makes sense? Those 4 red cards, we're not counting the red with the heads, because we don't want the heads. We're just counting the red with the tail. So it's 4 out of 40. Divide that on your calculator, 0.1. That's 1/10, right? How are we doing? That making sense there? Najwa. 40? Yeah, that's back over here. So there's 20 different cards, and each of those cards can go with a head or a tail on the coin flip. So it doubles it to be 40.
20 plus 20.
Right. Right. 20 cards with a head, 20 cards with a tail. 20 times 2. Does that make sense there? And red and tail, there's going to be 4 cards, because there's 4 red cards. And those are matched up with tails. So roll 2 dice. What are the different things that can happen when you roll 2 dice? Let me lay it out for you. So if you roll 2 dice, one of the earlier homeworks had this picture. I'll just make it for you right here. If you roll 2 dice, there's a lot of things that can happen. I'm going to make it a big array here. So when you roll 2 dice, you can get a 1 and then a 1. Or a 1 on the first die and a 2 on the second. Or a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. Or you can get a 2 on the first die. And a 1, 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. Sound like I'm an auctioneer here. 3 and a 1, 3 with 2, 3 with 3, 3 with 4, 3 with 5, 3 with 6, 4 with 1, 4 with 2, 4 with 3, 4 with 4, 4 with 5, 4 with 6. You get a 5 on the first die, followed by a 1, 2, 3, 4, 5, or 6. Or you can get a 6 on the first die, followed by a 1, 2, 3, 4, 5, or 6. There it is. How many different things can happen when you roll 2 dice? 36. 6 by 6 array, huh? When you roll 2 dice. Now, what are they specifically asking for? You don't have to, it'll be on YouTube. You don't have to copy it all down. They are asking for, let A be the event that either a 4 or 5 is rolled first, followed by an even number. 4 or 5 first, followed by even number. So here's what I'm going to do. I'm going to move this over. Okay. So 4 or 5 first. Let me write that. 4 or 5 first, followed by even number. What's an even number? 2, 4, or 6. Huh? All right, so out of all those 36 things that can happen, how many are a 4 or 5 first, followed by an even number? That would be a 4 with a 2, a 4 with a 4, and a 4 with a 6. Or a 5 with a 2, a 5 with a 4, and a 5 with a 6, huh? Right? It would be right here, here, and here. Right here, here, and here, wouldn't it? Those are starting with a 4 or 5, followed with an even number. Does that make sense how I got it out of the array there? And so what's the probability? The bottom's 36, right? Because probability, the bottom's always the total. And what goes on the top? 6. There's 6 different boxes, 6 different results out of the 36. And so if you, I don't know if they want a decimal. They do? So if you hit the buttons on your calculator, I think you get, I don't know what you get. Is it 0.16666? Is that what it is? Probably rounds to 167. What do they want? They want, 2 decimal places. So they want you to round it to 17, I think, right? 0.17. Is that making sense? Let's go back. And then part B, sum of the 2 dice is at most 5. At most 5. So let me write that. At most 5. The sum. The sum. So what the 2 dice add up to is at most 5. That means the sum can be 5 or 4 or 3 or 2. So that's here. Notice the sum, call that snake eyes. 1 and a 1. The sum is 2. Notice the diagonals hold the sum. So we talked about this before? Yeah. Diagonals hold. See, notice 1 and 2, 2 and 1, those both total 3, don't they? So that's the sum of 3. This is the sum of 2. Next diagonal. See that? 3, 1, 2, 2, 1, 3. What do they all add up to be? 4. Next diagonal. Whoops. There it is. I kind of went over a little bit. Right there. That diagonal. 4, 1, 3, 2, 2, 3, 1, 4. They all total 5, don't they? See how the diagonals hold the sums? And so again, it's out of 36. How many different results is that altogether? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different boxes out of the 36 boxes have a sum on the dice that's 5, 4, 3, or 2, at most 5. Divide that in your calculator, whatever it says. Is that good? Is that making sense? That's how they determine all the probabilities in craps. When you roll 2 dice, there it is. Or if you play Monopoly, or you play Settlers of Catan, I don't know if you ever know that game where they have the probabilities all laid out. That's how they calculate why certain squares are more valuable than others, because those sums are more valuable, more likely. What's the most likely sum when you roll 2 dice? What's the biggest diagonal? 7. 7 is the most likely sum when you roll 2 dice, followed by 6 and 8, followed by 5 and 9. Or, experiment consists of first rolling a dice and then tossing a coin. So if you first roll a die and then toss a coin, how many different things can happen? Yeah. Did I hear 12? That's 12. That's good. That's right. Yeah, because if you roll a die, let me move it over here. So if you roll the die, then toss the coin, what can happen? You can get a 1, 2, 3, 4, 5, or 6 when you roll the die, right? And then for each of those, you can get a head or a tail. A head or a tail. So you can get a 1 head or a 1 tail. A 2 head or a 2 tail. A 3 head or a 3 tail. A 4 head or a 4 tail. A 5 head or a 5 tail. A 6 head or a 6 tail. There's 12 possible things that can happen. In other words, it's 6 times 2. So now you just multiply those together. 6 times 2 is 12. So how many elements in the sample space? 12. Let A be the event that either a 3 or 4 is rolled first and then a head. 3 or 4 first and then a head. So 3 or 4 first and then a head. 3 and then a head. 4 and then a head. Those two are what they're specifying, right? 3 or 4 followed by head. So what's the probability of that? 2 out of 12. Because that's 2 of the 12 possible results, isn't it? 2 out of 12. Divide that in your calculator, I think it's 0.17 again. Because that's 1/6. So there we go on that. That makes sense on number 4. And that, all right, so quiz question number 5. So you have 9 cards. It'll change the numbers a little bit for each of you. But basically 9 cards. 4 are red, 5 are purple. And the cards are well shuffled. You draw 2 cards without replacement. So 9 cards, 4 red, 5 purple. Okay, so down here it says, what's the probability R1 and R2? Look, do you guys ever use any of these links? You ever watched any of those videos?
They don't pop up on my iPad.
Okay. So I thought they were pretty helpful. I've clicked on them a couple of times. It's the gentleman who writes a lot of these questions. Anyway, I thought he was pretty clear. Anyway, so check them out if you're having trouble sometime. R1 and R2. So what's R1 and R2? What's R1 up here? First card is red, second card is red. So they're saying, what's the chance that the first card is red and the second card is red? That's what they're asking. Bring it up here. So the probability, the first is red and what do we always do with and, by the way? What do you remember? Something we learned about and? Multiply. Yeah, and is always multiply, huh? So what's the probability the first is red and the second is red? Well, let's just start with the first. What's the chance the first card comes out red?
Oh, wait.
So how many total cards are there? 9 total cards, right?
Yeah, mine's different,
Oh, yes, everybody has a different number.
That's what
And how many of those are red? 4 out of, not at least on mine, 4 out of 9. So it would be 4 out of 9 and times. And what's the chance the second's going to be red? Same thing. 4 out of 9. Multiply that together. On the top, 4 times 4 is 16. On the bottom, 9 times 9, 81. Do they want, 2 decimal places? So let's divide that on our calculator. So,
is this quiz number 3?
Yeah, this is quiz number 3. 0.19. I got 1975, but it wants it rounded to 2 places. So that'd be 0.20. You guys okay with rounding that? 1975 would round to 0.20. Does that make sense how we did that? And means multiply.
Wait, why'd you have to put...
Let's go to the second part of this question. The second part says, what's the probability that at least 1 is red? How are we going to do that? Probability at least 1 is red. Do you remember we kind of made a big deal out of at least 1 questions? I don't remember. Sometime last week, Monday or Wednesday. Remember we had a certain formula? So let me move this one over. This is question number 5. So what is it? 4 red, 5 purple. So 9 cards. Is it cards? Whatever it is. 4 red, 5 purple. And they're saying you draw out 2 cards. Draw out 2 cards. And they're saying, what's the probability at least 1 is red? At least 1. Probability at least 1 is red. So remember, what was our formula for at least 1? 1 minus, not the first, not the first and not the second. Exactly, good. You guys have good notes. Yeah. Right, so 1 minus not the first times not the second. Remember that for that at least 1 stuff? So that would be 1 minus not the first. Now, not the first what? Not the first. Remember, it's always what they're asking. It's always not whatever they're asking. What are they asking for?
Green.
Well, at least on mine, red. Yeah, so not the first one being red and not the second one being red, or whatever color they're listing for you. So what's the probability that you do not get red on the first one, at least on mine? If there's 9 cards total, 4 of them are red and 5 of them are purple, not red, what's the chance if I pick one of those 9 out, I will not get red? 5 out of 9. Does that make sense? Because out of the 9 cards, 5 of them are not red. For my example, anyway. And then it's the same thing second time. Again, just 5 over 9. Is that making sense? So at least 1, like we've kind of run into it before, whenever they give us at least 1, it's always 1 minus not times not, and the not is not whatever they're saying, in this case, red. So not red, not red. And the chance you're not going to get red is 5 out of 9, because there's 9 cards and 5 of them are not red. And you can literally type it in just like that in your calculator, 1 minus 5/9 times 5/9, I could write that out. So you could just type in 1 minus 5 divided by 9 times 5 divided by 9 and hit enter. And I'll do it too. And I'm getting, for me anyway, I got 0.69. If they only want 2 places, 0.69. Do they want 2 places? Yeah, 2 places. So for mine, it came out 0.69. All right, so question 6. A Washington, D.C. tour company gives tours all year and offers a weekend tour, blah, 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 blah. So there's a big table with a bunch of data. Let's make sure that we understand what this data is saying. So Tell me about those 68 people. What do we know about that?
They go there on the weekend?
Yeah. They went there on the weekend and during the spring. So they took a tour of Washington, D.C. on the weekend during the spring. And these people took a tour of a 7-day, so not a weekend tour, but a longer 7-day tour in the spring, etc., etc. All right. Now, yeah, there's a lot of different options for the table. You might get one about skiing, or I think I saw some other ones when I was fiddling around with things today. Anyway, so if a customer is randomly selected, so if you pick somebody at random out of this group, what's the probability that they went to Washington, D.C. on a weekend trip? Probability of weekend. Yeah, right. 405 out of 530 total, huh? He's an excited math student. That's what I tell myself. All right. 405, so whatever. They want a decimal, I assume. I don't know what they want. Do you guys know? Does it want decimal? Or?
Answer a fraction either or using tallies given and reduced to lowest terms.
Oh, reduced fraction then. So remember how to do that? So you got to hit math enter, right? So you put that in. You can just hit enter there. And then after you get that, hit math, enter. So it wants a reduced fraction?
It doesn't give you the option to put it in a fraction. But it says your answer as a fraction.
It's pretty user friendly. It'll let you literally just type in 405 divided by 530. You don't even have to simplify it. That's what they're saying here when they say present your answer as a fraction, either using tallies given, meaning you don't have to reduce it. You can just use the same tallies that are there. I literally just typed in 405 / 530. I submitted the quiz, and it was happy with that one. It marked all the rest of mine wrong, but it was happy with that one. We good there? Does that make sense? It'll take it just like that.
I refreshed it. I still don't have questions.
I don't know. So probability in the winter, I think that'll be easy. Let's go down to C. 7-day and fall. So what's the probability that if you grab somebody at random, they had a 7-day pass and went in the fall? Yeah, the denominator is still the 530, huh? You can just go 7-day and fall, 15 people. There's just 15 people that went on a 7-day trip in the fall, huh? So in this case, the and actually means we just grab one. So when you have a big box, and means find where those categories intersect. Does that make sense? 15 people had a 7-day pass in the fall. So that'd be 15 divided by 530. We good there? Is that making sense? They're saying out of all the 530 people, how many went on a 7-day trip and went in the fall? 15 out of 530. D, what's the probability if you grab somebody random? There's somebody that went on the weekend or in the spring. What do we always do for or? Or's adding, huh? Yeah, or's adding. So can you add up the weekend? So I got to find the weekend. Where's all the weekend people? Wouldn't all these people be weekend people? And how many people went in the spring? We'd also throw in those 18. All the ones I have circled up there are weekend people or springtime people. Does that make sense? So I can just add all those up, divided by 530. So I'll just go 68 plus 18 plus 194 plus 97 plus 46.
405 plus 18.
7 plus 46. I'm getting 423. So that would be then 423. Change colors for clarity here. So that would be 423 out of 530. Does that make sense what I did there? I just added all those up. There's 423 total people that traveled on the weekend or in the spring. All those ones I circled. A quicker way really would have been just to take that 405. Oh, is that what some of you guys were saying?
Yeah.
405. Good, you're totally right. And just add the 18, huh? Yeah, just take 405 and add the 18. That would have been quicker, huh? Just get straight to the 423. Does that make sense? Yeah. Glad I thought of it. All right. We good? And then part E. Probability of a 7-day. So if you grab somebody random, what's the chance they were a 7-day trip given it was the summer? Now there's a given again. Remember what given does? Changes the denominator. Limits who you're talking about, huh? So if they say given, we're not talking about everybody now. We're given that they were a summer traveler. So given that they went in the summer, they definitely went in the summer, that'll be my denominator. It's the given, which is summer in this case, is always your denominator. Whenever they have a given, that is your denominator. And so how many went in the summer?
46.
Yeah, 246 people total went in the summer. And out of all those summer travelers, how many were 7-day travelers? 52 out of 46. So you just type in 52 out of 246. How we doing? Is that good for number 6? On that? Questions on that before I move on? Okay, and number 8, it says an experiment consists of tossing a penny, a nickel, and a dime. So we're tossing a penny, nickel, dime, and we're finding heads or tails. So how many elements are in the sample space? How many different things can happen? So the first flip, what is it, the penny? The penny, well, I really need more room. So first off, the penny. You don't have to write these tree things out every time, but I'm just trying to be extra clear. If you just know the answer, it's fine. It's not 6, though. So watch closely. The penny can be heads or tails. And then what comes next? The nickel? The nickel, which is flipped next, can be heads or tails. That's the nickel there. For the nickel. And then third comes the dime. The dime can be heads or tails. For the dime. So when all is said and done, you can have heads, heads, heads on the 3 coins. Heads, heads, tail. Do you see how many possibilities there's going to be? So yeah, so we're flipping one penny, and the penny's either going to come up heads or tails. And then after the penny, the nickel could come up heads or tails, and you could heads on the penny and heads on the nickel, or heads and tails. We're just branching off, and then the dime, heads or tails on that. Tail, head, head. tail, head, tail, 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 head, and tail, tail, tail. How many different things can happen? There's 8 possible, huh? 8 possible results. Does that make sense with the branching?
Yes.
Picture it in your mind. And coming back, what do they want here? How many elements in the sample space? 8, right? 8 different things here. 8 possible. Let A be the event that there is at least one head, and at least one head, and at least one tail. So rather than do any fancy at least formula, I'm just going to look at the 8 things and circle the ones that have at least one head and at least one tail. I think that'll be the easiest way to go. So, how about that first one? The head result. Does that have at least one head? Well, yeah, it's got lots of heads. Does it have at least one tail? No. How about this one? Yeah, that has... What they're saying is one of each. At least one of each. In other words, not head, and not tail, tail. Right? It's going to be all of these except for the ones that are purely tails or purely heads. All the rest have at least one of each type, don't they? See what they're saying? I don't know if you got a different question, but that's my question. At least one of each. So how many of the 8 different things that can happen, how many of those have I circled there? 6 out of 8. Huh? 6 out of 8. So 6 divided by 8. Do they want a decimal or what do they want? What does it say? That's right. So yeah, 6 out of 8. Remember how to reduce that? So it's 6 out of 8. So you got to type 6 divided by 8. Hit enter, and then remember how to reduce fractions on your calculator? Math, enter. Math, enter. And when you do math, enter, it'll tell you, and you probably already knew, 3/4, huh? 6/8 just reduces to 3/4, so it's 3. This one should go 3/4 is what my answer key shows there on it. Is that good? Are we happy? So number 9 is going to be what you're used to. But it's still hard, though. According to a recent poll, 58% of the registered voters support Measure R, 47% support Measure S, whatever they are. And 39% support both. If a randomly selected voter is surveyed, find the probability that the voter, and then they have a whole bunch of questions. So anything come to that? A lot of the battle on a math test is identification, isn't it? You read these questions, you're like, I don't know. I did all that homework. I did 100 questions, maybe 200 throughout all this stuff. Which one's that? They can all start to look at. So I want to help you with that, especially right before the exam. I'll give you. I'm going to do some. I'm probably going to make a special YouTube. I already did it for exam 4, and maybe 3. I don't think just 4. 4 in the final. I'll try to make up a YouTube. I had some students say that really helped them. So I'll try to make up a YouTube right before exam 2, where I just go through identification and say, you see this? Then it means this kind. So let's even start thinking that way now, though. What in here would help you know what to do? Do you see any unique? We've actually done one just like this even tonight, but you might not recognize it. What's it going to be? The table. Yeah, it's a table one. Good job. How can you tell that one's you need to make the table thing? Do you see there's 2 characteristics? There's whether you support Measure R or not, and whether you support Measure S or not. So some of the other ones were like speak French or English, male or female, right? Or I can't remember the other one, whatever it was. We started the night with those, huh? Yeah, so this is one of the and the way you recognize it is there's 2 characteristics. That's what needs to kind of jump off the page in 2 weeks, jump off the exam page for you. You see it and you go, oh, 2 characteristics. Got to make me a table. So let's do that. So I'm going to make a table and Measure R, Measure S. I need a little room, so I'll come over here. So question 9. So again, it doesn't matter which one you put on the top, which one you put inside. I'll just put R on the top, I guess. S on the side. And then it's yes or no. They support it or they don't. Yes or no for measure S on that. That's an S there. Okay, and let's go through the percentages. It says 58% support measure R. 50, I'll write it over here on the side. 58% support R, and 47% S. At least these are my numbers. 47% S. And 39% both. Okay. So, all right. So 58% measure R. Where do I do that? Right there, huh? Is that good? 58% support measure R. Why don't we start going to decimals? I'll just go 0.58. Doesn't really matter. And right, because that's the R total, isn't it? That's the yes R total. And then 47% measure S. That's right there, huh? That's the total yes for measure S and the total yes for measure R. Is that good? And 39% support both. Where's that go? The yes, yes. The 39% goes right there that are support both, huh? They're yes on both. So now we can find the other ones that are missing by subtraction, huh? Right? So 0.58. So 0.58 minus 0.39 is, what is it? 19, thank you. 19. So that must be 0.19 there. And same thing here. This is 0.47 minus 0.39, 0.08, right? On that. 0.08. And like, how do we find what's the final box? Yeah, it got to be 100 total, huh? So for this box, if you take 0.39, 0.08, 0.19, which that goes to 0.6, 0.66, and 1 minus that would be 0.34. So that box is 0.34. That way everything adds up to 100%.
Wait, how'd you get 34? 0.34.
Yeah, right? I added up the 3 that we had. I added up these 3 right over here and got 66, and then took that away from 1. Because altogether, this has to be 100%. So subtract from it. Yeah, that's the tricky step. Is that good? So this is just like it's a tricky version of the French-English one. And now we're ready for the questions. So what are the questions? It says, if you select a voter at random, what's the chance they support neither measure? Support neither. So part A, neither. What's that going to be? How many are neither supporters? Yeah, right there. It's the no. They support neither. 0.34. Part B, supports are given. There's the given, that key word. They support S. Are given S. So, well, I should say yes on R. Let me make that more clear. Yes on R given yes on S. Yes on R given yes on S. Right? Is that what they're saying? Supports R given they support S. Yeah. So yes on R. What's the probability of yes on R given that they're yes on S? You know the given always is the denominator, huh? That limits the possibilities. So that would be yes on S. So the given yes on S people. How many people are yes on S? Yeah, these people are yes on S, 0.47. And of those, how many are yes on R? 0.39 out of the 0.47, huh? So what you can do is, again, put that into your calculator, hit the math, enter. I think it'll just come out 39 over 40. Yeah, I know it will. Just come out 39 over 47. Oh, they want decimal? Oh, okay. Never mind. Give them what they want. They want a decimal. 2 places or what? 4. Okay, I'm getting 0.8297 or 8298 actually. It would round 8298. Like that. Is that good? And finally, question C. Support S given support R. So that's the same thing other way around. I really want to get on the last 2 or harder. So I'm going to move on. So you could do C. It's the same thing. Just flip it around, right? All right. So this is number 10. So 12% of the students at the college are vegetarians. 31% of all students at the college have majors in the Division of Arts and Humanities. Out of the students with majors in Arts and Humanities, 18% are vegetarians. Student is selected and find the following. Now, right away you recognize, oh, it's just 2 characteristics again. That's totally true. But they have an extra curveball. It is. It's generally the same as the last one, but with an extra curveball. So let's set it up. This is number 10. We're going to have our big box thing. And what are the 2 characteristics we're talking about on this problem? Did you recognize them? What are the 2 characteristics that somebody can have or not have? They're a vegetarian or not. And? They're part of the arts and humanities, or not. Doris has a mind of its own. So, right? Those are the 2 characteristics we're talking about. So we can go up here and say, are they a vegetarian? Yes or no. Are they part of the arts and humanities division? Yes or no. See how there's always 2 characteristics? All right, and let's go put the stuff in. It says 12% of the students are veg. Let me write that out. This is where we want to be a little more careful. 12%, watch what the of is, of the students. That means of all the students are vegetarian. So that's the normal way they say things to us. In fact, let me, I don't got room there. Let me put it down here. So 12% of the students, of all the students, are vegetarians. So you know that's the way it normally is said. That'll be right here, 0.12 right there. That's the vegetarian yes people, right? That's the total vegetarian yes. Nothing new so far, huh? That's pretty standard. Next fact. 31% of all students. Notice again that word, because they're going to change it on the third one. It won't be so on the third one. 31% of all students, that's the way they normally say it, at the college, are arts and humanities. So, write that down. 31%, again, of all students are arts and humanities majors. So, okay, we can do that. No big deal. 0.31 there, huh? Because that's the yes, arts and humanities total. 31%. Now, normally, at this point, they give us a third one. They will give us a third one, but it'll be a little different. It's going to say 18%. Oh, and well, let me begin the sentence here. Out of the students with majors in arts and humanities, not out of all students, notice. They do not say 18% of all students, blah, blah, blah. That's what they normally have done in all the rest of the problems we've done like this. But here there comes the curveball. They're doing something different. Out of the arts and humanities, let me write that. So, out of the arts and humanity people, out of that group, not out of all students, but just out of that group, 18% are vegetarians. 18% are vegetarians. So what are they saying then? It's not right for me to come in here and put a 0.18 there.
You have to put down the
Is everybody good so far that that's not right to do that? They're not saying, if they said 18% of all students of all students, arts, humanities, vegetarian, boom, yeah, I put it right there, yes, yes, boom, boom. But it's not all students, is it? See how it's, so let me go back here for a second. See how it's different than number 9? See the wording on number 9? It says, 58% of registered voters are R, 47%, same thing, RS, and 39. Those are all of the registered, of the registered, of the registered. They're all out of the same group, aren't they? They're out of everybody. See on question 9, those percentages are all from the whole population, aren't they? Whereas on number 10, the first two, 31% of all students and 12% of the students, those are out of the whole population. But the third one, that 18%, that's out of the arts and humanities people. So I need to take 18%, let me rewrite it this way. 18% of arts and humanities are vegetarians. That's the same sentence said in a more helpful way. Do you see that's what they're saying? 18% of the arts and humanities people are vegetarians. So why I say it that way, let's do the math on that. 18% is 0.18, that you know. What is of always in math? Times. Of is times. Of is times. Arts and humanities. Well, how many arts and humanities people are there? Or what percentage? 0.31. I'll make it blue for color clarity. Right? So we got to multiply that in our calculator. I'm getting 0.0558. So that's what goes here. Why did I grab the 0.31? Because that was the arts and humanity group. It's 18% of that group. It's 0.18 times that group, which comes out 0.0558. Of means times. It's that portion of that group. Does that make sense how we came up with? See how that's different on those words? So now that we have that, now we can get the rest by subtraction. The rest is normal. Let's get it by subtraction, right? We'll take 0.12 minus 0.0558, and that'll equal, I have no idea. That'll equal 0.0. 0.0642 for there. Right, good. So I'm just doing by subtraction now, like normal, right? Same thing up here. 0.31 minus 0.0558. And I'm getting 0.2542. And how do we get the final box? Yeah, add them all up and subtract from 1.0, huh? Yeah, 100%, 1.0 decimal. Exactly. So to get that final box, I'll come up here and I'll add 0.0558, 0.2542, 0.0642. Add them up. Just going to use my calculator. I'm getting 0.3742. Whoops, I forgot to do the 1 minus, huh? That's what all those categories add up, so what's left over, I'm going to have to do 1 minus, which I almost forgot. So now 1 minus 0.3742 is 0.6258. go. Now we're in a position to answer their questions. Do you see the different trick on this one? That third percentage was not a percentage of the whole population. It was out of the arts and humanities people. So it was 18% of the arts and humanities, 0.18 times the arts and humanities total, 0.31, 0.0558. And then the rest is the same. Subtraction, to find the other two boxes, add up, subtract from 1. Now we have all the boxes. Let's answer the question. What's the probability of vegetarian? If you grab somebody random out of their group, what's the chance they're a veg? It is just the 0.12. Right, that's all the veg people. Just 0.12. We just read it right off there. 0.12. What's the chance they're arts and humanities? 0.31. It's just straight off right there. What's the chance they're vegetarian and arts and humanities? That's right here, because that's yes and yes. They're both. 0.0558. Do they want 2 decimals or do they care? Whatever, I'll just move on. And finally, arts and humanities given vegetarian. Remember given? The denominator is the given always. So the denominator is the veg. Because that's what's given. Given veg. So given vegetarian. What's that? That's the 0.12. That's the vegetarian group, huh? 0.12. And the top is arts and humanities. Within the vegetarian. That's the arts and humanities part of the vegetarian. So, right, because, whoops, I'm on the wrong screen here. So here's the veg group. And for that group, 0.12 total, the arts and humanities is 0.0558. 0.0558. So divide that on your calculator. I'm getting 0.465. Bless you. 0.465. So that last part was a little tricky. Is that good on that one?
When you select the answer,
Yeah, they might have rounded something. So just grab. They didn't specifically say how far to round. So yeah, grab the one that's really close to that. See how question 11's coming at you? 46% of all statistics classes are calculator. 38% require the use of a computer, I guess. So it's the same thing, but then notice this phrase, of the classes that require a calculator, 18% also. See how that third one's of again? It's going to be the same thing as last time. Same thing as number 10.